what I did was for Lab 3, we used the SparkFun controller, their little proto board that you'd have a joystick and then 4 buttons. And the joystick was really bad quality, so.
It's okay.
It works for Heather.
Positive.
And then she crashed.
In front of the professor over and over again.
Once in front of the professor.
So we decided then, I took an old Xbox controller and ripped out the 2 joysticks and then put a takeoff and land button in the middle and a potentiometer so we could switch between those. And that's how I built the controller.
Code for it ended up being really easy then, because we could just take analog values, convert them to table indexes, and just put the speed value we needed straight to the drone. Yeah, it was a pretty sweet setup.
Yeah, it worked very well.
It didn't change very much between Lab 3 and Lab 4, right? It was just like a little bit of
Just
streamlining.
adjusting how it worked.
Because you guys set individual commands, right?
Right, for Lab 3. Yeah. And then this time
In a
we
bunch of
packaged
ifs.
them together.
Yeah.
Which made the maneuvering pretty awesome.
Yeah.
You could do corkscrews and stuff.
Yeah, it was able
Especially
to.
because Lab 4 we used double joystick, so we could do some
Yeah.
really awesome stuff.
And you were able to control it very, very easily.
You can move in like the 3 different directions at the same time.
Exactly.
Well, we initially tried to use as much of the nav data as we could, and we found out it was just really hard to access reliably. So we ended up going with just a timing-based scheme where we measure an amount of time, we go forward, forward, and then we just tuned it till we got it close to the path we wanted. Which ended up sucking. We'd have the same
It
kind
was
of
so
code
bad.
and have different results each time by several feet.
So did you do anything to improve that?
We had a couple ideas, but ran out of time. We wanted to do some tag stuff to sense where we were, and we thought about doing some stuff with the inertial sensors, but next
It
time.
ended up being 4 loops.
Yeah. Didn't you guys think it was like a UDP packet loss?
That's our best
problem?
guess.
Yeah.
Yeah.
Yeah, because there would be times where it would just take off, sit there, and then book it backwards. Like, I mean, how random.
The other stuff.
I mean, what? Like, you lost 200 packets of forward? I mean, what's going on?
That was a lot of fun.
Yeah.
I mean, we had to do a lot of brainstorming and try and figure out, because we thought everybody was going to do a tag detection and follow the ball, but we thought a drone following a drone would be like the coolest idea ever. So it was actually not too difficult in code, but in practice it was pretty difficult because of stack sizes and because tag detection was really spotty at first. We had to change color a couple of times between tags, and
That
actually
made a
we
big
found
difference.
orange-yellow was the best tag. I mean, having a big stack size was great, but then the adjustments for the stack size, we ran into problems with the max string length and AT commands and some other things. But all in all, we tried to do 2 tags to do rotate, but we got up, down, left, right, and forward, backward implemented, so we were pretty happy in the time that we had.
It looked pretty cool.
Yeah,
Yeah,
stoked
it
with
ended up being pretty good.
yeah, and we flew it, for the second time at the competition, and it worked. So,
Thank goodness.
hey, sometimes it works. Yes.
Yeah.
Yeah.
Until we what's going wrong.
I think this is also like my first time working in a large group setting where you have to divvy up parts. There's no real leader, but yet you have to work as a team coherently. And I think, I'm really proud of these guys because we've worked as a team. I mean, really, really well.
So did the drone help you do better in the class as opposed to you?
Yeah. It definitely
What would
made
the
it.
class be like if you didn't have the drone?
Oh, if we didn't have the drone, it was a lot easier to work harder because you had the drone. Because
Just
that was kind
excited
of our
for it.
debugger a little bit.
You get something to take off the ground.
Yeah, it's so much
and
more
fly
awesome.
around, and it's a lot neater than, oh look, there's a squiggle on a board. I mean,
Yeah. Or the
Great.
motor on the board as it spins. Fun.
Yeah.
Like, yeah.
And it's a lot more practical this way. A lot more fun. We have drones in the military all the time. You got to figure out how to use them, how to program them. Scheduling algorithms mean something more when you actually have to use them with a physical representation. Deadlines, it falls out of the air if you don't have it
Yeah.
working. So.
Versus just a line or a light not showing up or
Yeah.
something.
It was nice doing something that brought recognition to the department too. I mean, with
Yeah.
all the media
That
and
was
stuff.
cool.
Yeah.
That was pretty
cool to
awesome.
see our work
Doing the
get
obstacle course.
shown.
People
Yeah.
interested.
Yeah.
Jonah is also very angry that this
Yeah, we can set it as wide as